So in today's lesson, we're going to carry on from yesterday's introduction to completing the square and tackle a few more challenging questions. So we're picking up where we left off. I'm going to strongly encourage you to view the first video where I teach you how to complete the square before attempting any of the questions in this video. So here we have another question where I'm being asked to determine the vertex and then sketch the curve. We're going to kind of park the sketch the curve bit because we've done that in a previous lesson, but we will talk about maybe what we might expect to see from this curve. So when I look at this function, I can see right away that it's not in vertex form. And so if I want to identify the vertex, I need to complete the square. So you might be thinking, well, this looks a little different than what we've seen in previous examples. And there are a couple of reasons that I'm thinking you're feeling that way. So first of all, I can see that the coefficient here of my first term is 1/2. We haven't seen any questions with fractions as the coefficient of the squared term yet, so I'm going to go through a few different examples where that's the case. But it does tell us a few things. It tells us that we're going to expect our graph to be compressed by a factor of 1/2 and also to be opening up. So that is essentially our value of A. What it seems to be missing here that we can assume is there is like a +0 for our last term in the quadratic. So there is no constant term here at the end. It's just sort of we don't have a placeholder, but if we had to put a placeholder, it would be +0. So that is a little bit different, though. You're going to see how that plays out, and it's really not going to be a big deal at all. Okay. So we're going to start this by doing what we have always done when completing the square, which is to remove the coefficient of our squared term and pull it out of the first two terms. So that means I'm pulling out that 1/2, and that's going to leave me with x squared plus something. And this is where I often will see students put in 1/2 of the value of my x term, and that's not what you should do. Let's just take a look. Let's just see what happens when I do that. So if I put 6x there, then what happens if I go and I try to go backwards and distribute that 1/2? I should end up with what I started with. Let's see if I do. So 1/2 times x squared does give me 1/2 x squared. 1/2 times 6x does not give me 12x. It gives me half of 6x, which is 3. So what should I have there? Well, I should have 24x instead. And that way, when I multiply the 1/2 in, 1/2 of 24 gives me 12. So I have what I started with. Okay. So that's one strategy you can use when working with simple fractions. So let's move through our next step. So the next thing that I need to do here is I need to take 1/2 of this term, the x term, and square it. So I'm going to do that on the side, and this you can do this in your head, but let's just show it for argument's sake. So I would say 24 divided by 2 squared. Well, that gives me 12 squared, which is 144. So I'm going to go ahead and I'm going to add that in and then subtract it out. And the point of that, the purpose of that, just to remind you, is to create that perfect trinomial square. But I can't just add in a value, but by adding that value in and then subtracting it, it's really like I'm not changing it, because this would, these would combine to give me 0. But now in the first 3 terms inside the brackets, I've created my perfect trinomial square. So now what I'm going to do next is I need to deal with this negative 144. I need to get it out of the bracket. So that means I need to multiply it by 1/2, and then that will move it outside of the bracket. So I'm going to go ahead and do that. And so 1/2 of 144 is 72, so minus 172. And so there I have that. All right, so now I'm just about done. I'm going to go ahead and factor my perfect square trinomial. So 1/2, and you'll remember that I have to create my brackets and then squared, and the minus 72 is going to go outside. I'm going to take the square root of my first term, which is an x. I'm going to take the square root of my last term in that trinomial, which is 12. And I'm going to use the sign of my x term, which in this case is positive. So there I have done it. So I can tell from this that my vertex, which is at h and k, is going to be negative 12 and negative 72. And then done. Hopefully you followed that reasonably well, particularly the part of it that was new, which was that A, I have this fraction, and also B, when I had that negative 72 out of the brackets, there was nothing else to combine it with, which is not really that big of a deal, but something worth noting. Okay, let's tackle a harder question. Before we look at the next question, which involves a fraction that's a little bit more complicated, I want to circle back to that initial question that we saw today with the 1/2 x squared. And I want you to think about our strategy that we used with that fraction in a slightly different light. So one way that you could think about, removing that 1/2 from both of the first terms is you could sort of think about it almost as though you had said, well, I need to say 12 divided by 1/2. Now that doesn't look very nice, does it? So let's rewrite it as 12 divided by 1/2, right? Because I know if I'm saying 24 times 1/2, then that led me to 12. So if I simply just reverse this process, I'm really just saying 12 divided by 1/2. Well, I'm not sure if you remember how to divide fractions, but really all I do when I divide fractions is I take the second fraction and I invert it and I multiply. So in other words, to do the division with the fraction, I need to take that second fraction, invert it, so 2 over 1, and then I can change the sign to 1/2. And you can see very quickly that when I do this, I end up with 12 times 2 divided by 1 is 24. Lo and behold, that was the value that we got over here inside of our brackets. We didn't need to use this strategy because the question that we were working with wasn't terribly complicated. But we're going to look at an example where the fraction is a little bit harder to visualize. So we're going to apply this strategy there. So here's another example where we're going to try that strategy in action. Now, of course, this is just one of many possible strategies. If you're very comfortable with fractions, then maybe this is not an issue. Some of you may be thinking, well, I can just convert that fraction to a decimal, but I would be cautious of that, particularly in the case where you have a denominator that is 3 or 6, because that will give you a repeating decimal, so your answer won't be particularly accurate. Okay, so I'm going to start this question by doing exactly what we've done for every other completing the square question, which is to start to remove the coefficient of my squared term, which in this case is 2/3. So that's going to leave me with x squared plus something else that's going to have to go in this spot right here, and I have yet to figure that out, plus 5. And it's not really obvious because that fraction 2/3 is messing me up a little bit. So this is where I would do this work on the side. I would say, all right, well, I know that I have to take 8 and divide it by 2/3, right? So I'm going to apply what I just did with fractions in the earlier step and invert and multiply that fraction. So 8 times 3/2, which is what I get. And so my rule when I multiply fractions is I'm going to multiply denominator with denominator to give me 24. And there's really an understood denominator of 1 for my 8, so 1 times 2 will give me 2. And so I end up with a value of 12. So that tells me that I can go and insert that 12 up here as 12x. Now, if you're not believing me, you can try this out. So let's just go ahead and do a bit of a check here. So if I'm right about this, then I should be able to multiply 12 times 2/3 and end up with 8x again. And I just noticed something that I'm going to fix, which is that the coefficient of my x is, my 8x is negative. So I'm going to go ahead and I'm going to fix that, which means that means that this 12 is also negative here. And kudos to you if you notice that. All right, so yeah, back to checking. Here I'm going to do my little check. So 2/3 times negative 12, multiplying that out, I end up with negative 24 over 3, which will give me negative 8. And that's what I was expecting here, so I'm good to go. Okay, so I was right, and that process worked. Now I need to carry on with the rest of this completing the square, and you can see that what I'm left with is actually pretty nice to work with. So I'm going to create a little, I'm just going to create a little whiteboard here so that I can get rid of that and have some new space to work. So now it's business as usual. So I would encourage you to pause the video, try to complete the square with the remainder of the question, and then take the video up when you are ready to check your work. Okay, so I removed the 2/3, so that's just hanging out there, and it tells me that this is, this function is going to open up, and it's going to be about 2/3 of the size that it was before. So I have x squared minus 12x on the side. I'm going to take my negative 12, divide it by 2, and then square it. So negative 6 all squared is going to give me positive 36. So I'm going to add in 36, subtract out 36. And then add in 5, which was there, and I'm not going to touch it. Now I need to remove my negative 36, so I'm going to multiply it by 2/3. I'm going to show that step on the side here. So 2/3 times negative 36. Remember, if you need to put that as a fraction over 1, to remind you that you're multiplying numerator with numerator, negative 72, and denominator with denominator over 3. And that will give me negative 24. So now I know that when I write it on the outside over here, it's going to be written as minus 24. So let's carry on with that. So y equals 2/3 times x squared minus 12x plus 36. And I've got my minus 24 plus 5, the 5 that was already there. And let's clean this up a bit. So again, feel free to skip steps. I'm going to combine a couple of steps here. I'm going to say, well, I need to find the square root of x squared and the square root of 36, and then the sign of my middle term. So that's going to give me x minus 6 all squared. And so negative 24 plus 5 is going to give me negative 19. And so there I have my vertex. So my vertex is at 6 and negative 19. And I'm done. Hopefully you did okay with that. Let's try one more and see if you can apply some strategies to solve it. So I got to tell you that in the quote-unquote real world, very rarely do we end up with nice, beautiful mathematical models that are whole numbers. In fact, in chemistry, we see numbers that are decimals all the time, and usually they're very large or very small numbers. And in grade 12 chemistry, we'll have to be able to solve an equation like this. But what you're asked to do here is to complete the square to find out where the vertex is for this particular function, and so I want you to apply the same strategies as we have. I want you to actually try this before I show you the solution, just so you can think your way through it. Okay, so pause the video and resume when you're ready to check your work. All right, so I'm going to begin this question by doing what I've always done when I complete the square, which is to remove the coefficient of my squared term, and in this case that's 0.48. And I'm going to leave that as x squared minus, and then I'm going to need something else there, plus the 0.53. So the big question is, well, how am I going to get the value that goes in here? So really what I'm saying to myself is 0.8 times what is going to give me negative 1.2. And so the way that I can solve that is by reversing that equation, if you will, and doing a division just like we did in the last fraction questions. So I would say negative 1.2 divided by 0.48, and we'll see what that gives us. So I'm going to pull out my calculator to do that. So 1.2, even though I can see I probably don't need to, divided by 0.48, and that's going to give me negative 2.5. So I'm going to go ahead and put that value in here, minus 2.5x. And again, I can check this by simply multiplying it out. Does in fact 0.48 multiply by 2.5 to give me 1.2? So I'm just double checking 2.5 times 0.48, and yes, it does. So I'm good to go. So now I'm going to do what I've always done. The numbers just aren't so pretty. I'm going to take my negative 2.5. I'm going to divide it by 2, and then I'm going to square it. I'm going to do that in one step just on my calculator. So 2.5 divided by 2 equals, and that will give me 1.5625. And there is no instruction here for how to round, so we're just going to keep that whole thing in there. So it's kind of ugly, but it is what it is. I'm going to just shift this over here. Y is equal to 0.48 bracket x squared minus 2.5x plus 1.5625 minus 1.5625, and then plus the 0.53 that was there before. I'm going to hide some of this. All right, and so now I'm going to start with my next phase, which is to get rid of my negative 1.5625 by multiplying it by whatever is outside the bracket. So here I go. I'm going to again need my calculator for that. 0.48 times x squared minus 2.5x plus 1.5625 minus 0.75, and then of course I still have the plus 0.53. Okay, now I'm in my final step where I'm just going to clean everything up. 0.48, I'm going to take the square root of x squared, which is x, sine of my middle term, square root of 1.5625, which should be 1.25, all squared, and then I'm going to sum up the last terms, and that gives me, unless I'm mistaken, please correct me if I'm wrong, 0.22. So now I have it set up. I have a value for my h and I have a value for k, and so I can say that my vertex is at 1.25 and negative 0.22. So that's kind of ugly, but probably more representative of how you would actually use this type of model in the real world. Okay, so if you found those a struggle, that is reasonable, and it will take practice for you to kind of be fluid with this process. So I'm going to encourage you not to give up and to work through it. We're going to do one last question, which is a word problem. Okay, so let's just read through this question. I'm just noticing that this should probably be example number 3, so let's just redo that. So the question reads, the cost C in dollars of operating a machine per day is given by the formula. C, which is representing cost, is equal to 2t squared minus 84t plus 1025, where t is the time in hours the machine operates. So presumably, if we think about this, well, I can tell by the value of a here that this is a parabola opening upward, and that it's stretched by a factor of 2. The vertex, we're going to, maybe be able to figure it out. But really, if we think about, well, what is a parabola showing us on a graph? It's showing us this would have a minimum. And so if we draw in some fake axes here, just to kind of get a bit of a visual on this, we know that the cost is dependent on the time, right? And so if you're in business and you are operating a machine, you want to know what you want, the minimum cost, right? So when a question asks you for the minimum cost, really all that you're finding out is the minimum value for the parabola, which we of course can get from the vertex. Now in this question, they're also asking for how many hours must the machine run to reach this minimum cost. So this is an example of where in business you might utilize a quadratic function to model a particular circumstance, financial circumstance or other, within your company. So what do we have to do to take an equation that is written in standard form and get into vertex form? Well, of course, we need to complete the square. So I'm going to encourage you to pause the video and give the completing the square part a try, and then answer the problem's question. And then we'll take it up in a minute. Okay, so take a minute to check out my completing the square work to see that it matches yours and to highlight any errors that you might have had. Now comes time for us to analyze the results. So as we saw earlier, C is sort of like Y and T is sort of like X. So in the context of the vertex, which is an X and Y coordinate, we really know that in our standard form that becomes our H and our K, right? So for our vertex here at 21 and 143, we can match it up to the variables that we see in our equation. So in other words, the 21 represents T, and the 143 represents C. And so by matching those up, that allows us to easily reflect on what the meaning is for each of those values. So if T is representing, if 21 is my T and T is representing time, that's telling me that at 21 hours of operation is where I have a minimum cost, and that minimum cost is $143. So I'm just going to bring back the question for a quick minute. It says, what is the, where T is the time in hours the machine operates, and C is the minimum cost of running the machine. There we have it. So now if we go back here, we can then definitively say that therefore, after 21 hours of use, the cost of operating the machine is $143. And that is it. So I know that the questions today were a little bit more challenging. Again, I'm going to encourage you to give some of the practice questions I assign a whirl and to struggle through them and to reach out with any questions that you might have.